Hello friends, so in our previous part 3, we have already seen the real coefficient A, but just a little bit of recall of last class, and then we'll proceed for the next. So what we are studying is, we have total coefficient. If you see the total coefficient we have to study is A, B, C, D and E. So right now we are studying coefficient A. In coefficient A we have two types. The first one is real coefficient A, and the second is apparent coefficient A. Apparent coefficient A and the real coefficient A. In real coefficient A, we have plus A and minus A. So plus A we have already seen in previous class, which was easterly. Deviation was easterly in all heading, and now we'll see this minus A, in which the coefficient, the deviation will be westerly on all 360 degree. So this plus A is because of minus B plus D rod, that is plus real coefficient A, and this minus A will be because of plus B and minus D rod, which I have already drawn here. This minus D and plus B rod. Now you know how it is plus and why it is blue. So just I will explain one. Here it is blue because it is forward of the compass, and the effective pole is forward of the compass, so it will become positive. It is become positive, and the farther pole is starboard of this effective pole, so this is also positive. So this is plus. That's why it is plus B. So it is plus B rod. I'll just rub it. Plus B rod, and this is minus D because this one is being effective pole being on port side is negative, and the farther pole is forward of the effective pole, so this is positive. So plus minus, so this one become minus D. So this plus B and minus D. So these rod I have drawn for all cardinal and intercardinal direction. Now we'll see how it will deviate, how the westerly deviation will be there. So I'll just rub this, and we'll see the deviation over there. So you can see here the magnetic line of force is coming from south or from the down. So how this become blue and red? See, so this is the this is totally horizontal in respect of the magnetic line of force. So it will not get induced, this rod, that plus B rod. In here it is not totally horizontal, so it will induce a little bit. Here it is totally horizontal, so no induction. Here on all heading, wherever it is horizontal, it will not induce, otherwise it will induce it. So you know, then wherever the magnetic line of force is entering, that will become blue. So this is blue, and so that therefore the other one become red. Here this is the nearest to this, so it will become blue. Here also it is nearest to the magnetic line of force, so it will also blue, and the other one will become red. This one blue, red, blue, red, blue. This one become red. This blue, and this red. Now how will it will become westerly deviation? We'll try to understand this. So let's start from here. So because this rod, this B rod plus B rod is has not got is not induced actually, because it is horizontal on broad on side of the magnetic line of force, so it will not get induced, so it will not deviate anymore. So here, and I have already told you in our previous video that we will only study for the red end of that needle. So the red end is here. Red end of needle will get attracted by this blue pole. So how will it deviate? It will deviate in this direction, because red and blue it will attract, and so it will deviate in this direction. So this is what is westerly deviation. In this one, if you see the effective pole is this, the red one. So here it is red, and here also the compass is also red. So this one will repel, and the force will become like this. Here it is blue, and this one is red, so it will attract towards it. So there are two forces. When we'll resolve this, we'll get a resultant. The resultant will be somewhere here. So this is resultant. So the deviation is again westerly. So the westerly deviation. What will happen here? The red end of the needle and red end of this effective pole. So this one will repel. So it will come to this, and this is not induced, so it will not affect. So this is also westerly. So westerly deviation. What will happen here? This red will repel this red, and so this one will go there. This red and this red, it will repel here. So the resultant will be somewhere here. So there is the westerly deviation. What will happen here? It's only because these are not got induced, so it will not affect anymore. So only this red will deviate the red end of the needle. So how will it go? It will repel, so it will go to the west. So westerly deviation. How this one will affect? This red will be repelled by this red, so somewhere here, and this blue will attract this red, so it will be somewhere here. So the resultant will be somewhere here. That's why it is westerly deviation. Here the only one is blue here, so this one will attract the red end. So here also westerly deviation. Here what will happen? this one will attract, the blue will attract the red, and this blue will attract the red. So here, so the effective, the resultant will be westerly. So we can see on all heading it is westerly. That's why when we are studying the coefficient and A, B, C, D, that time I told you that A is circular. Circular in sense that on all 360° the same deviation will be there. If you go to the semicircular, you will see that on half of the circle it is easterly or westerly, on other half will be opposite of that. So that is semicircular. In quadrantal, you will see there will be 4 types of deviation. In all quadrant there will be different type of deviation, but here on all 360° the same deviation. So we saw in real coefficient A plus real coefficient. So right now we are studying is minus real coefficient A, and plus real coefficient, everywhere it was easterly deviation. On all 360° only one deviation, that was easterly, and on westerly on this minus real coefficient A, on all heading 360°, the only one deviation, that is westerly. Now a question is being asked that, now rubbish, one question is being asked here in our exam also, written exam, or it might be asked by the surveyor in oral also. The question is, what is the cause of easterly bias? So easterly bias, when it was easterly bias, the easterly bias was in plus real coefficient A. So plus real coefficient was because of minus B and plus D dot, which is on our previous video, previous part. There it was plus real coefficient A, in which on every heading it was easterly deviation. So this easterly bias is because of this minus B and plus D dot. The same question will be asked that what is the cause of westerly bias? Westerly bias, then that will become because of the minus real coefficient A, and because what is causing that minus A? So this plus B and minus D rod, which just now we saw in this video. Now we'll see how it cause. As I told you, we will study all the coefficient in 5 points. So now we know the definition, we have already studied. What is the cause? So cause is minus B and plus D rod. Then the nature was on every heading plus, when we are on real coefficient A, then on all heading it was easterly, and in minus real coefficient A, on all heading it is westerly. Now we'll see change in deviation due to change in course on our next slide. Okay, so first point we have already done. This definition we have done, the definition of coefficient A, and then cause also we have done. Now the nature we have done. The second part is the change of deviation due to change in position. So for this one I have just drawn here, this is Earth and this is suppose the equator, magnetic equator. Now one position I have taken here a particular latitude, suppose this is any latitude, and the one another latitude which is higher. So here suppose the H1 which I have already studied in our Earth magnetism. H1 is the horizontal component of the magnetic field, and Z1 is the vertical. So H1, Z1, and at position 2 the H2 and Z2. So now we'll see how the deviation is changing. So I have drawn here a graph in which this one is representing horizontal force and this one is representing the force which is being resulting from the deviation. So this force F1, F2 I have mentioned here. So what is that? Suppose H1, we know in our Earth magnetism we have already studied that H is maximum at the equator. So H is maximum here, and Z is almost nil here, Z and nil. When we go at the pole, so at pole H is, you can say, nil and Z is maximum, and in same respect it is increasing or decreasing up to pole from this equator. So what will happen here at H1 first position, this latitude it is near to the equator, so H will be somewhat less than the equator, but at least it will be more than H2, because on as soon as you are going towards the pole, then H, the horizontal component, will decrease. So here the H1 I have taken here because H1 is more than H2, so H1 is here, so H2 is here. So how? Because in this one we are studying, and all this coefficient A either plus or minus A, it because of the induced magnetism. So if it is induced magnetism, the what is the cause which is inducing it? That is the Earth magnetism. The magnetic line of force is coming, and that force is influencing our this horizontal means any soft iron, whatever is there, like in our A coefficient we studied about the minus B plus D or plus B minus D. So that particular rod is being influenced by the Earth magnetism, and that is depend on the totally depend on this H1 and Z1 of Earth magnetism. So however the value of H1, that will influence, if H1 is more, that will influence more, Z1 is more, it will influence more. So which factor is there? So if H1 is more, so it will induce more, so the value of the resultant force deviation will be more here. H2 it is because less than the H2, so in the same respect, because the same force is inducing both, so H2 will be somewhat less than this point. So H2 is M, and it is coming on the same line because the same force is inducing that particular rod. So the force here because of H1 will be somewhat more here because it is here only near to the equator. So the force will be here, and H2 is somewhere more higher. So H2 is higher on higher latitude, but the value is less. So the value is less, so it will deviate in same respect, and that's why this value will be less. So there will be, so the only one this force will be creating by both. So the deviation because of this H1 is this one, suppose this one, so deviation 1, and because of this H2 will be, as it is coming on the same line, so suppose this one, so deviation 1 and deviation 2 is same, means deviation it is not affecting the deviation. So we can say the resultant, we can say no change in deviation due to change in position. If you feel any doubt on understanding in this point, you can text in our comment box and I will explain again. Now the second point we have studied. Now the this is the third point. So the directive force is, now what is directive force? So directive force I told you it is in the north direction. What is the this magnetic force? How it is influencing the north direction? So in coefficient A, either plus A or in minus A, we saw that it is not affecting anymore. So the no change of directive force on any heading, hence mean directive force. Or if it is on particular heading it is increasing, on other heading it is decreasing with the same rate. So the mean will be 0, mean directing force will be 0. So there will be no change. Now the correction, if suppose you are at ship and you saw that your magnetic compass is showing such type of variation, then how will you correct this? So mean deviation, we need to swing our vessel in at least 8 heading or preferably 16 heading. If you are observing that error on 16 heading, that will be more, that will be better for your better, that will give the better result. So 8 heading will be also okay, and that will be actually whoever is service provider, you can just consult with them and they will ask you the heading or the deviation on particular either 8 heading or 16 heading, whatever they are asking you can give them. So preferably 16 heading, otherwise 8 heading. So north, northeast, east, southeast, south, southwest, west and northwest on all heading, and just divide by 8, you will get a mean deviation. You will get a mean deviation. That deviation, if that deviation is giving positive or negative, means easterly or westerly, because I told you here it is circular, so it will give either easterly or westerly. It cannot give both. On particular heading it is giving something else, or on particular heading something else. It will be either easterly or westerly. So if it is easterly, then how to correct this? So in this type of correction we don't need to do, we don't have to correct with any soft iron, soft magnet or any permanent magnet or something. So what we have to do is, we know the lubber line of our compass. In the lubber line, either in our compass one mark is marked towards the north. So that lubber line we need to adjust. So either if it is coming easterly, means your compass is showing somewhat in on east side. So just rotate your lubber line on clockwise deviation. So I have written here, if required to adjust, turn the lubber line. Lubber line we need to turn. And just change the compass, no, so that error will be no more. So just turn the lubber line on clockwise direction. In the clockwise direction, if the deviation is easterly, and vice versa on anti-clockwise direction if it is coming westerly. So this is the way how we can correct the this correction for easterly or westerly bias. And this is all about real coefficient A, that is plus real coefficient A and minus real coefficient A. Now the second one will be apparent coefficient A, which is not because of the any induction or any permanent magnet. That is the some other reason, which is we can say the index type of error. We'll see 3-4 points are there. So what all the points are there which is affecting this, we'll see in the next. Now we'll see apparent coefficient A, which is the last of this coefficient A. So apparent coefficient A, I already told you, this is not because of the factor of ship's magnetic field. So the definition I have written here, if you want you can copy. It is a constant value. So it is a constant value, means it will be remain same at all heading or of error, which remains same in sign and magnitude, for all direction of ship's heading. On every direction it will remain same and is caused by factor other than the ship's magnetic field. So ship's magnetic field is not affecting this error, not affecting, and it is not because of the ship's magnetic field. So some other index type of error are there. So what are that? The first one is, if you see in the compass, the 0 degree and 180 degree, it is marked on your compass ball. So on your compass card actually. So the 0 degree and 180 degree not parallel actually. The 0 degree and 180 degree not in exactly in a parallel line of the magnetic axis of compass needle. So your compass needle is showing, if your compass needle is showing 0 degree, and if we'll exceed the compass needle on the opposite side, that will be not matching with the 180 degree. Means your 0 degree and 180 degree, suppose your needle is somewhere here and 180 degree is somewhere here, means it is not parallel actually. It is not parallel. So if this type of error, that is a constructive error. So if this type of error is there, it is might be because of this. So this coefficient might be because of this, which we need to verify. The second one is 4.5 lubber line is not parallel to the 4.5 center line. Like your compass has been made here, and suppose one lubber line is here, another line is here. So this lubber line is not parallel to the vessel center line. Your vessel center line is somewhere else, and it is not parallel to that. So whichever bearing you are measuring with that compass, that will give some error, and that error is equal to the whatever the error, means how much it is deviating from the 4.5 center line. So that this might be another reason. The third one is index error of azimuth mirror, the one which we used to measure. If there is some error in that particular thing, like prism, azimuth circle, prism, or azimuth mirror, so that might be the reason. Or the other one might be you have applied wrong variation. So because of the wrong variation, application of wrong variation, you might get this type of error. So this may be the another one reason. And other is wrong application of hour angle, which we use to calculate the side or something when we are measuring to the from the compass, either from the repeater or from the center repeater. So these are the 5 region of apparent coefficient A. So this is all about the coefficient A. Now we'll see 2 questions. One is which is being asked in our exam multiple times. It has been asked multiple times, or it is the same is being asked in the oral also. So that question is important for our exam purpose of view as well as for the oral purpose of view. And the question is, what is Gaussian error and what is retention error? So that both error we'll see, and thereafter that will be the end of this coefficient A. Thereafter we'll start coefficient B. Yeah, so the important topic is Gaussian error. So this is the one which has been asked many times in our exam, in written exam, and with in oral also. Actually the surveyor asked me only this, what is Gaussian error, and he asked me to explain it briefly. So we need to understand here. So Gaussian error is because this error was given by 2 scientists. The first one is by Faraday, and the second one is Lenz. So some Faraday law was there, and thereafter the Lenz law. So I will just dictate the what is this Gaussian error. If you want, you can switch on your subtitle on your YouTube, and you can write from there, or I will just dictate, you can write it. So first we'll write it, and then I will explain. So what is this Gaussian error? So just write it. According to Faraday law, whenever a conductor, this is a conductor cuts the line of forces of the external magnetic field, like this is a magnetic field and this is a conductor, it is cutting at varying speed. So external magnetic field at varying rate, it get induced with an electric current as per Lenz law. So that was for Faraday law. So now you can write, as per Lenz law, the current so induced, as I stated above, create its own magnetic field, which acts in opposite to the motion which induced the electric current. So what does it mean? Like suppose there is a external magnetic field and there is a conductor. So if we are rotating this conductor, or we are rotating the magnetic field with respect of this conductor, so that this conductor is cutting this magnetic line of forces. This all magnetic line of forces, they all are the magnetic line of forces. If this conductor is cutting this one, and suppose that time you are rotating this one in clockwise direction, either your conductor or your magnetic field, what is creating the magnetic field. So if you are rotating it, so as per the Faraday law, it will create a current. A current will be induced in this conductor, and that was given by the Faraday. Now the Lenz, what the Lenz law told, that current which is being induced in this conductor, because as per the Faraday law, this current also induced a magnetic field in this conductor, but that magnetic field will be opposite of that. Opposite of what? Opposite of that which create the electric current. So what is which cause electric current? This magnetic field. So suppose that time we are rotating this one in clockwise direction, and because of that clockwise direction, one electric field was creating, electric current was inducing in this conductor. So that current cause a magnetic field in this conductor, but in that time, now that magnetic field will be opposite. Like suppose if it is it was because of the clockwise direction, and suppose this was blue pole and this was red pole, so the magnetic field created here will become opposite of that field. So that was what we written in our definition. So according to Faraday law, the current is induced in this conductor, and according to Lenz law, that current is also creating a magnetic field in this conductor, which is opposite to the cause which induced it, means the magnet which created the current in this one. So therefore, a ship, when we are swinging our ship, so therefore a ship swinging to a starboard side for adjustment of a compass, like when we need to adjust the compass and we are swinging our vessel towards the starboard, then it is somewhat we can say the clockwise direction. So swinging the vessel to a starboard side for adjustment of compass, or observe of bearing, either for adjusting or for observation of bearing. So experience of westerly. So if we are uh, changing our course of the vessel towards the swinging towards the east, but it will give a deviation on west, because of the deviation on east, the current is creating on this whole ship, you can say, as a conductor. Whole ship is acting as a conductor, and whatever the earth magnetic field, that earth magnetic field is being cut by our ship. So if we are swinging towards the starboard, that magnetic line of forces are being cut by that conductor, means the ship, and that is inducing a current in our ship. And as per the Lenz law, because of that current, one additional magnetic field is being created on our ship hull, or all the longitudinal girder, or whatever the rods are there. So that magnetic field will be opposite. Like suppose we are swinging to a starboard side, but the deviation will be westerly. So we can write, therefore a ship swinging to a starboard for an adjustment of the compass or observation of a bearing experience westerly Gauss-in error, whereas a ship swinging to port side to adjust the compass or observation of bearing experience easterly Gauss-in error. So to avoid such type of error, whenever if we are taking a bearing or we are adjusting our compass, you just have to swing our vessel on a particular heading and just steady there for at least 2 seconds, at least for 2 minutes, and then only you take any bearing, or observe any bearing, or take any bearing for adjustment of your compass. So this is about the Gaussian error. So why it is important? It is important because whenever we are swinging continuously our vessel, we should not take any bearing at that time. That might be, there must be some error. And as well as when we are adjusting our compass, we must swing our vessel for a particular course, and then we steady for 2 minutes, then only we take the bearing. That bearing will be correct, otherwise it will be there will be some error, and the adjustment will not be correct. Now we'll see what is retention error in the next. Yeah, now we'll see the retentive error. By the name itself, it is clear that something is retentive, means something is retained in that particular thing. So retentive error is nothing, it is like suppose this is your vessel and you are continuously sailing for a considerable period of time. Considerable period, I mean 2 days, 3 days. Like if you are on a long sailing, you are going cross the ocean, like you are crossing the Atlantic or Pacific or something, in which your vessel is going continuously on a particular heading. So what happened that time? Your vessel is at that time, when I was talking about 3 types of magnetism, in which I told you permanent magnetism, subpermanent, and one is induced. So subpermanent, I told you that time that there is only one question that will define later. So this is what is subpermanent magnetism, because of the subpermanent magnetism. So what happened actually, vessel is continuously progressing on a particular same heading. So what happened, because of, I told you how the permanent magnet form. It is because of the repetitive heating, striking, vibration, or such type of activity, in which the each and every element of that particular material get aligned in a particular direction, and that direction, that particular element is influenced by the either the north pole or south pole, and according to that rearrange itself and it behaves like a magnet. So same thing happens here. It is not because during the permanent magnet it takes months, 1 month, 2 months, because when we are constructing a vessel, when the keel laid on a particular line, that time it will remain for 3 months, 4 months, till the vessel is totally constructed. So at that time it is taking too much time and it becomes permanent magnet. But in this condition, in retentive error condition, the vessel is continuously heading on same heading, but it is not for a very long time. It is for 2 days, 3 days, 1 day, or 10 hours, 15 hours, like this. So what happens here is, when vessel is on steady course for a considerable time will be anything, 1 day, 2 days, 5 days, 7 days, whatever. So a certain amount of subpermanent magnet, I told you that time. So this magnetism, for anything to happen, is required some heating or vibration or some heating, striking or something. So what happened actually, the subpermanent magnet in the structure with red pole northward. Suppose this is north, and this is south. So red pole is constructing toward the northward and blue pole on southward of the compass, due to vibration, ponding, etc. What we actually experienced when vessel is underway. We used to get vibration because of the machinery, because of the wave action or some other actions, and ponding also because of the wave action we experience there. And because of this, the element of that whole ship is align, it try to align in a particular direction, but since it is not for a very long time, so it take time and it realign in their particular direction. So it is only a sub-permanent magnet, not a permanent magnet. So what happen? So when a course changes, it retain for few hours. So when actually, when suppose a red pole and blue pole is created on the vessel due to the action, due to the permanent magnetism, so what happen? It when we are altering our course, then even this pole remain for few hours, during which period they decay. Means that time it takes few hours it takes to decay this temporarily on this magnetic pole. So what happen when we are on particular course, and that time now we are about to turn our course. So if we are altering our course towards the right of the original course, suppose you are going towards the north and now you are altering towards east. So what happen up to 180 degree, like suppose you are going 0 0 0, so up to 180 degree if you go on the right side, so that time what happen, your magnetic compass will say westerly deviation here. It will show westerly deviation. Why? Because you see it has formed a red pole here and blue pole here, and your magnetic compass is continuously swinging in this direction. So it will try to remain in the same direction. It will remain in the same direction. And the same time, when you are altering this course, the red end of your needle will be repelled by this red, so it will remain on this side, and this blue will attract. So it will show here. Although your vessel is on easterly course, but your needle is swinging somewhat towards the north, so it is westerly course if you are altering your course towards the right. Same thing will happen if you are altering your course towards the left up to 180 degree, up to 180 degree from your original course. That time it will try to remain in the same direction. That is what the retention, it will try to remain in the same direction. So it will try to remain in the same direction, but at the same time this will also repelled by this one, because red and red end, so this one will try to repel, so it will go away from this. So that time it will show easterly deviation. So this is about the retention error. So when we are altering course, what precaution we are supposed to take, I have written here so that you can note down. So compass error should be checked frequently over the next 6 hours, because we consider that 6 hours is enough to decay that effect. So 6 hours it take various time this compass error, so as the retention error gradually reduce over the period or decrease over the period. So that time don't take any because that time if you are taking any compass error or something, that will give very large deviation, and that will not be correct. So to verify that, we need to check the we need to take the bearing frequently over next 6 hours, and maybe after next 6 hours it will reduce to 0, and there will be no any retention error available in your ship's hull or in your compass. So this is all about the retention error. So now so far we have studied all the in our coefficient A is completely completed now. And now in the next slide or in next part, we'll try to not try, we'll start with the coefficient B, and thereafter in that one we'll see what is the permanent coefficient PB and what is IB, means induced. So now I think it is more than enough for this part. So in this part we'll stop here only, and thereafter with coefficient B we'll start in the next part. So I will request you to please like, share and subscribe to your subscribe also, and please share to your friend, so that it can encourage me for making more video. Thank you for watching, and I will start with the next video in the next part. Thank you.